So let's take a look at an example. I said before that Bayes' theorem is interesting because it relates the probability of E given F and the probability of F given E. And these two things often feel quite different. They have quite a different flavor. So let's see an example of what kind of thing that is talking about. So, example, for the setup, we're just going to have a simple little counting type thing. So let's say we have two boxes with red and blue balls. So let's say we have box 1, which has two blue balls. Actually, let me use colors here. Why not? Don't really do that too much. So it's got two blue balls in it. And it has got 7 red balls. And then we have box 2. So box 1, 2 blue, 7 red. And then box 2 will have 4 blue and 3 red. So 3 red balls and 4 blue balls. There we go. So let's consider the following problem, or the following sort of procedure. Choose a box at random, and let's do it uniformly, in the sense that the probability of choosing each box is 1/2. Then choose a ball from that box, again, uniformly at random. So since we're choosing uniformly, that means, for example, if we choose box 1, there are 9 balls total. So each ball has a probability 1/9 of being chosen. Box 2 only has 7 balls. So the probability of each ball in box 2 getting chosen, if we chose box 2, is 1/7. So our warm-up question, let's say E is we chose a red ball. Let's say, yeah. And F is the event that we chose the first box. So what is the probability of E given F? So if we are given F, which means that we chose the first box, what is the probability of observing E, which is that we chose a red ball? So this is essentially just saying, what is the probability that we choose a red ball from the first box? Like if we just choose a ball from the first box, what is the probability that it's red? And that is 7/9, because, like we said, they all have a 1/9 chance of being chosen, and 7 of them are red. So now, what is the probability of F given E? So this is just the E given F is just the probability of choosing a red ball from the first box, the probability of F given E is given that we ended up with a red ball, what's the probability that we had chosen the first box? So this is a good example of how these things can have quite a different feel to them. So the probability of E given F, on the one hand, is just take the first box. What's the probability of choosing a red ball? Fairly straightforward, 7/9. We can just compute it straight out. But the probability of F given E is slightly more mysterious, because somehow it feels more like it's asking, given that we observed some outcome from our experiment, what can we conclude about what caused that outcome? So we ended up with a red ball. This is some kind of evidence or some kind of data that we have collected. What is the probability that we chose the first box, which is sort of some kind of hypothesis about the world? So it's not clear at all how to compute this straight out, but this is exactly what Bayes' theorem is designed to do for us. So of course we will use Bayes' theorem. So the probability of F given E is the probability of E given F times the probability of F divided by the probability of E. So we just need to compute each of these three things. So this one we've computed, no problem. What is the probability of F? So F is the event that we choose the first box. And like we said, we are choosing that thing at random with probability 1/2. So P of F is 1/2. Now, what is P of E? The probability that we chose a red ball. This is slightly more complicated, but like we said earlier, we can compute it as the probability of E given F times probability of F plus probability of E given F complement, probability of F complement. So this is just saying, in this case, it's essentially saying how many ways can we choose a red ball? Well, we can choose a red ball from the first box. What's the probability of that? Well, the probability that we choose the first box is 1/2. And then having chosen that, the probability that we get a red ball out of it is 7/9. Or we can choose a red ball from the second box. What is the probability that we choose the second box? It is again 1/2. And given that we chose the second box, what is the probability of getting a red ball? It should be 3 red balls divided by 7 balls total. So that is 3/7. And if you multiply this out, this is 38/63. And now we have all of our ingredients for Bayes' theorem. Let's go ahead and plug them in. So the probability of F given E is equal to, so this thing is 7/9. This thing is 1/2. And this thing is 38/63. And in total, this gives us 49 divided by 76, which is about 0.65, just if we want to get an idea of how big this is. So 65% chance. And if we look at our original picture, let's think about what this is telling us. And if we think about this intuitively, it turns out that it should match our intuition. Because if we ended up with a red ball by following this process, then intuitively we should expect that it probably came from the first box, because the first box has a higher proportion of red balls. And Bayes' theorem is giving us a way to quantify this. In fact, given the composition of the two boxes, we are about 65% confident that it came from the first box. And I guess the probability that it came from the second box is then, the complementary thing, 35%, 0.35. So there is a first example of Bayes' theorem.